Okay, so hey, ouch! Don't do that. That hurts. Um, what are we doing? Oh yeah, hey, we're here to do a review on. I don't know how much of a review it is. You're just going to watch me work a test. I guess that's a review. I'm assuming it's helpful because nobody's ever come out and said, "Hey, stupid, do something different. That don't work." Anyway, uh, oh, this is going to be a long review. No, it can't be. Okay. Hi. Um, review. Exam two. Engineering 1030. I don't think I have any 1040 students this semester. I think I started with one, but they dropped. Um, anyway, so this is all the covering the materials since the first exam, although the basics that you learned in the first six chapters are still included here because you can't do some of this work without knowing how to do the other stuff. So anyway, okay, so we're going to start here. This is the exam that I gave actually in the spring this year. This test has 9 problems on it. Um, I worked the exam just before coming here, and it took me like 45 minutes to take the exam, which is about standard. If I can do it in between 45 minutes and an hour, it'll take students up to 2 hours to do it, which makes sense. I've been doing it longer. Um, so anyway, so we're just going to start here, and I'm going to run through. If you have any questions, pop up or send a chat. I'll try to keep an eye on the chat window, um, and then I'll just go. And hopefully, I don't make so many mistakes. You're not supposed to make any mistakes. You're the teacher. Yes, but I are human. Okay, jury's still out on that, but it's perceived that I am human. Okay, are we ready to start yet? Okay, we're starting. Okay, so problem number one: acceleration, force, and mass are related by using the following equation: mass equals force equals mass times acceleration. The constant force of 100 newtons is applied to 5 different masses. Solve the equation for acceleration and find the value of acceleration for each of the masses. Okay, so this is pretty simple, straightforward. Mass is already given. Our force is given as 100 newtons. Let's suppress that. No, suppress it first, but then do a comment and put our units in here. And then I'm hoping you can do the simple algebra to solve that equation for the acceleration. So acceleration is going to equal our force dot divided by the mass. And we have to dot divide because we're dividing by a matrix. And that should give us five. It should give us, come on, give me something. There it is. There's our five accelerations based off of this mass and that force. Okay. So next is create an array representing the force of 10 newtons that is the same size as the acceleration and mass. Now, why we did 10 newtons there and 100 newtons up here is beyond me, but that's what it's supposed to do. So we are going to do a force is equal to 10, and then it's got to be the same size, so we're going to multiply it by the ones variable of 1 by length of our mass. So that should give us 5 tens or a $50 bill. Oh, you're stupid. Oh, thank you. Um, uh, Holler if I'm going too fast. Okay, I'm just chugging along. Oh, we got to get rid of this thing. It's going to drive me nuts. Okay, create a table array called FMA with the column headers of force, mass, and acceleration and show the mass under the headers. Must use table function for full credit. Okay, so we're going to have a table array called FMA that says table, and then we're going to put in it our force, and it has to be transposed because it's a row vector. And then what was next? Mass transposed and our acceleration transposed. And then we have to have our variable names, and it's going to be force, it's going to have a little tick up on top, and then mass, and then acceleration. And those are the wrong brackets, right? Anybody catch that? Anybody? Uh, I just changed that. These aren't supposed to be square. They're supposed to be curly. Okay, and let's look at our pretty table. Chink. Oh, hey, that is so cool. I mean, I'm just in awe of how beautiful that is. Okay, and then 3 points is to recreate this using the disk function and the printf, and using one place decimal for accuracy. Okay, so we're going to say a display, and we're going to have force in the first column, and then mass in the next column, and then x. I did that again. Acceleration at the end, and then we're going to do an f print f. And in our f print f, we start with our first placeholder, which is a percent sign. And if we look at the table up here, there's just 2 digits, but it also says to have a one place decimal of accuracy. So that's going to be 1, 2, 3, 4 characters. Um, one of them is a decimal point, and we'll do a floating point. And then we'll come down here and we look at the mass, and the biggest one is 10, so we'll do the same for it. So we'll have the same floating point, 4 point set aside with one decimal and a floating point digit. Once then, acceleration is basically the same thing. We get 16 to get all that displayed, so it too will be a 4.1 F, and then don't forget to do a new line so that it prints it out right. Once then, we come in here, and on the first row, we need to have one row for every placeholder. We got 3 placeholders, so our first row is going to be the force to go in the first column. Then our second one will be mass, and then our third one will be acceleration. And that should give us a proper format for our table. Look at that. Isn't that cool? Say, yeah, man, that's just totally righteous, dude. Okay, so this one lines up with the S. Yeah, maybe we could take one space off that. But this one needs to go over a couple spaces just to kind of line it up a little more gooder. I do not take points off if you're not lined up to my standard. Okay, but try to make it look nice. So anyway, so there is problem 1. Any questions, comments? No? Okay. We go on to problem number 2, which is the problem that comes after 1, but right before 3. And there's a dot right here on my screen, so if my thing squiggles, that's because I'm getting rid of it. It's driving me nuts. It's right in the middle of the screen. Okay, so here we go. Problem number 2, worth 10 points. Consider the normal distribution function and its associated constants. So there's a gnarly equation and a sigma value and a mu value. Create an anonymous function for x of x. Okay, it doesn't tell us what to, okay, we'll just call it f. And it's going to be an anonymous function, so we start with an @ sign, and inside parentheses we put our variable, which is an x. And then if you want to take the time to type all that out and make sure you don't make any mistakes, more power to you, but I'm a fan of cut and paste. And then just make sure that everything's kosher, because there's 1 divided by square root of 2 times times, and then explanation. So we lucked out, and that one works. But first off, we got a problem here because we're using a sigma in our equation that is undefined, so we need to come up here and define it, and we're also using a mu, and oops, that one's 0, and we got to define that. So there's our anonymous, that function that goes inside the main function, the body of your anonymous. There you go. And we'll suppress the output. Okay, next is create a plot using fplot where x ranges from -2 to 2. Okay, that's easy. We did this back in chapter 5, I believe, 4, 5. Chapter 6 was, I don't know. It was a while ago. So we got an f plot and our function, which is f, and then our range, which is a -2 and a 2. and place title. Oh man, see, now I didn't get 100% on the exam I just when I wrote this because I didn't do a title. Title is um, a non-e-func. Um, and then access names, y label is what is the y? Y is f of x. There we go. F of x. And our x label is going to be something. Let's be unique and call it x. Yeah, nobody's ever used that before. No periods, dots, and then grid on, and adjust the axis so the y varies from. Okay, so limits is going to be um, minus two, and then I think is that I don't use axes that often, so we'll find out if I'm doing this right or not. Minus two, and then 2.5. Let's see what happens if it blows up in my face and say, "Ha, you are stupid." Ah, well, it threw. Okay, it didn't like axes. Okay, maybe I just do it without these. No, I need to do. See, I didn't read the whole problem when I did it earlier. Sorry, sue me. No, okay. All else fails, go to the cheater. Let me see. X-Men. Okay, so it is right. I just got to put square brackets around the whole thing and not just individuals. There we go. That's more hunky and dory. See, I skipped these two lines here and went straight down to this one here. Use G input to locate the approximate maximum Y value for the function and its corresponding X axis. So we're going to do an X at max Y and then a max Y is going to equal G input. And then if you put a value in here, that means it'll take 1 point and then quit. Let's print those on the screen so you can see them. So we'll run that. Oh, we got to have an equal sign in here. And it'll pop up a window. Where's my window pop up? There it is. And then we pick where we think the maximum value is, and boom, it canceled the G input and gave us some values. Is that cool or what? Say, yeah, man, that's cool. Okay, and then this one is to use sprintf to create a message and use it in the text box near the maximum. Message should look like this. Okay, that's cool. We can do that. So let's create a variable called note, and we'll use the sprintf. Once then, we are going to. Again, I'm going to cheat, and in here you have to double cheat, and then we're going to delete that. Trust me, this is a lot quicker than waiting for me to type all that crap in there. We need that one a little bit longer here so I can see everything. Okay, and then it says, but just before approximately, we put a line return and put a line return here. But for here, we're going to have a placeholder which is going to be, if we look up here, there's 6 characters, 4 digits, and a decimal point, so we'll go 6.4F. And the same for the max Y, or the max X, so that's going to be percent 6.4F. And then down here, we're going to have um, our max Y and our X at max Y. And then we'll suppress that. And now when I was playing with this a little before, well, it might work a little more gooder because I didn't do the axis thing because you couldn't read it. But still, you could still manipulate the placement a little bit. So I did a text box. Um, um, I did max Y. So my X, so I shifted that just a little bit so it wasn't right on top of the dot. So I just added a 0.1. And then on my, oh wait, I got that backwards. This is supposed to be X. This is X at max Y. X comes in first, then the Y. And I dropped it down just a little bit. And then we'll add the text, which is just going to be our note. And then we run that, and we get a nice little chart, and it's put over here. But see now, if we take this and get rid of that and run it all together, it puts it all on one chart. Where's my screen? Here it is. Yeah, twink. See, now isn't that just lovely? See, it tells you the max is almost 398 at 0.0. I mean, I'd almost get to 0. So, cool. Okay, questions? Okay. This problem, I don't think this one was in the homework. I'm pretty sure this one was in the homework, but this one wasn't. So this is a calculation of the value of pi that was developed in the 15th century, and we use a midpoint loop break loop to implement for a for loop. So we got to do a little homework here first. So we're going to be adding successive calculations, no, not equals total. I'm going to start that off equaling to, actually, I'm going to set this equal to 3. Why are you doing that? Well, because up here, see, 3 is outside of the stuff that needs to be in the loop. So if we start off at 3, then every time through the loop, it's going to add all this stuff. Because 3 only shows up once. All this shows up in a repetitive fashion. And that's why you would use a loop, because it's nearly the same thing repeated over and over and over, where the 3 is. So I start out here with the 3. Well, then I think that's all I need to do. So if we go forward, and I'm going to use K because I'm going to steal their equation. No, I got to write the equation out because I can't copy it off there because it's an equation writer. Equals. I'm going to give it an ample opportunity to converge. So I'll give it possible 20,000 iterations. And then we're just going to start with total equals total. Okay, so we'll do a running total here. And then we're going to add in the equation. So we're going to have an alternating sign of this. So that gives us a plus minus plus minus. And then if we multiply that by 4 divided by, and then let's put each of these terms in brackets just so we know what we're doing. We got our 2k times the a2 times k plus 1 times a 2 times a k plus a 2. And that should be everything. I got too many. This equals should be a plus, not an equals. Are you stupid? Yes, I am. Thanks for noticing. Okay, and then we'll do a midpoint check, and it wants us to check it against the value inside the MATLAB value, stored value of MATLAB of pi. So we'll do an absolute value of pi minus total is less than or equal to, oh, that's what I did. I knew I had two variables out here. I'd find an epsilon, which is 0.001. Maybe that's why it was so far different. Because I only had 4 iterations in this, but then the next problem where we're doing it in a while loop, I had 10,000 iterations. Why is this so different? And it's because I had a different epsilon. Because you're stupid. Oh, thank you. And then if it's base set, then we'll break. So we'll end the if, end the for, end the for, end the for. There we go. And then it says to just print out the screen the number of iterations you did. So we'll print out K, but I'm also going to print out my total to see where my pi is at. And we're going to run this. Boom. So it ran 13 times. So 1.1417. That's not 4 places. But that, I don't know. 0.14159. 15, that's 0.2. I think my MATLAB is going screwy, but or either that or the teacher. One of the two. You guys still awake? Okay. I just talking to myself.
Still awake.
Okay. Okay. So that was doing with the for loop. We didn't know how many times we wanted to run, so we put a very large number so that it would run far enough. But obviously, I put in a lot more than I needed because it only ran 13 times. So down here on problem 4, a less efficient way. Okay, maybe that's the difference because this one's much less efficient, and you'll see it's much. See, that did that in 13 turns. Is using this Gregory Leibniz, this guy's series. I can't even read English, and you give me these foreign names to read. Yeah. Anyway, he's got this series, and I know we did this one in the homework. Can be presented by alternating with that fraction. Do a while loop. Do not do a midpoint break, but put the convergence criteria in the while statement. Um, and then everything else is the same. So we're going to have, again, our total here, but this time we're going to start our total is equal to 0 because everything in here in the series repeats. This is 1 times 4, 1 times 1 over. So we're going to put 4 in, down there, and then we'll do all this up here. And then I'm going to do another epsilon just because if, someday down the road I want to change that to 0.02, I don't want to have to search through all of my code to find out where it was to change it. So I can just change it at the top. Okay, so now we're going to do a while loop, and then we're going to start off with while pi minus our total is, this time we're going to go greater than, and we're just going to go greater than our epsilon. Then it's going to do this. It's going to go total equals total plus. See, I got plus this time instead of an equal. Yay me, I'm learning. You can teach an old dog new tricks. Raised to the k plus 1. And then that's going to be multiplied by 4, which is divided by 2 times k minus 1. And this time, though, that we didn't do in the for loop, we have to increment our k. Otherwise, you'll just sit there and calculate the same number over and over and over. Come on, I'm hitting the shift button. Criminy. I have enough problems without the computer. We're on cap locks. Must have been hitting cap locks instead of shifting. Okay, and so there's that series. And again, I'm going to print out my total to see how close I am to pi, and then my k. I'm going to save this in case it crashes and I can't get back, because I want to be able to post this with a video so that you guys can What? Oh, right here. Drop the T. I. Oh, okay. So we got to have another one up here. And the first, this has got, the series starts at k equals 1, so we got to initialize at k equals 1. Are you going to throw anything else at me? Oh, see, yeah, now it finally, see, this one, to me, this one is more gooder because this came to 3.14159, which is within this range where this one up here is 1.147, which is, that's double this. That just doesn't compute. Am I off my rocker, or do you guys agree with me that that's wrong?
I agree.
But how? Because we're doing, maybe if I get rid of the equal sign, it's still the same. I don't know. I'm gonna have to take that one to Holly and say, Holly, why is this? This doesn't compute. Okay, these get quicker as we go here. This one was probably the hardest of those that are left. Quit scrolling the screen. You're making me dizzy. Okay, so consider the air quality data collected in Harriman, Utah during the first 9 months of 2022. It is stored in a .mat file called Harriman AIQ data. I don't like .mat files because it only stores the values and not how they're created. However, I didn't create this exam, somebody else did. So anyway, so we got to load the file, which is Harryman AQI underscore data dot mat, and I think it's still in my current folder, right there. Yep. Okay. And then that's going to load in two variables. If get out of here, go back workspace. If I load this in right now, you'll see a date and a Harriman AIQ. Okay, for me to write Harriman AIQ over and over and over again, guaranteed going to be an error. So I converted to something a little more user friendly, like data. We like data. He's an Android. Oh, sorry, no Star Trek references during the class time. Okay, so okay, now this is what threw me for a loop because okay, now we can't be using, we're not teaching the find command. We're using the in logical indexing. So I did everything up here in logical indexing, then come down to problem 6 and it says use in logical indexing. So I had to go back up here and do this over again. Although I only had to change one line to make the two difference. Okay, so anyway, so if we set a variable here, I'm certain you guys have a little bit of in, uh, 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 introduction to the find command. Um, so what it does is you tell it to find, you tell it where to look, and what to look for, and that will return the index values um, for every element that meets that criteria. See, it says greater than, not greater than or equal to. It says greater than. So we run that. It should give us. So those are the indexes. Those aren't the values. Those are the indexes. That's locations within that. Um, well, my data and Harriman AIQ where the values were greater than 100. And then to find the actual values, you go back into data and look at the index and the location. And so there are your values that were greater than 100, 112, 115, 143, and 101. So that's how you use the find index. And then determine the dates. Well, that's easy. Uh, dates is equal to, and then date, and again, the same index. So, I mean, this literally gives you the date. Day, month, year, everything. And then store both the date and the AIQ values for the dates that exceed AIQ in a table array. Okay, so let's just, it didn't tell us what to name it, so we'll do a table. And as you can see right now, the way these printed out, they're already in column vectors, so we don't need to convert them. Um, we ought to label these so I don't have to do it all over again. And then we got dates. So table 9, huh? How about we can do table 9, and then we'll do, let's do the dates first. Dates, and then, what did I change that to up there? See, I have brain damage, I tell you. Dates 100, and then we'll, give variable names, and then this time I'm going to do it right and put a squirrely bracket down for this, and then, the first one was, date. And let's try to spell it right, make our table look more gooder. And an AQI. And a closing parenthesis. And voila. That problem's done. I hope I'm not going too fast for y'all, but I guess you can watch the video and slow it down. Okay, find both the value and the AIQ of the corresponding dates using logical indexing. You do not need to create a table to report your results. Okay, so uh, so we'll do an LI index, which is logical indexing, and that we're just going to do data greater than 100, greater than 100. And what this is going to do is it's going to return a vector. Sorry, that's a baddie word in this class now. It used to be the only word, but now it's an array. It's going to send us an array that is 237 characters long, and for every element that meets this criteria, we'll have a 1 by it. And I can prove that. See, look, 273 characters, but you got to get down there into the 200 range before you start seeing some ones. I mean, fast them. They're there. See, but to get the what are we looking for? Oh, we're looking for the AIQ or AQI, right? Yeah. So so the LI AQI equals then we'll just do data and LI index, and so geez, we get to the same spot. And to get the dates, you do the same thing. Spell it right. Okay. Any questions on that? Comments, wants, needs, desires, concerns, complaints? Okay, we will go on to problem number 7. A placement exam directs which math class a student needs to take. If X represents their score, then X yada 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 yada. Write a code that prompts the user to enter exam score, returns a message telling user what math class they need to take. Because it's so hard to look up here and say, I got an 85, oh, I got to take college algebra. Oh, it's the principle of the subject that we're trying to learn, not necessarily an easy way to do this. Okay, so first thing we need to do is prompt the user for a score equals input. Uh, please enter a score. And then we're done. That was cool. Oh, no, wait, we got more to do. So we're going to start off with if score is less than 70, we're going to start at the bottom and work our way up. We're going to display, and we're going to cheat and use the right code. You must take remedial algebra. Then we're going to do an else if score is less than 90. Display. Yeah, I know you guys could probably type that in a lot faster than I can copy and paste, but I'm tired. I'm old. Can't teach an old dog new tricks. And then else, because everything else is going to be, no, else display. You must do it right so it doesn't go all fooey. You must take calculus. There you go. See, I can't spell either IR or digit. And I was on the wrong side of the parenthesis. Would you quit doing that? And then we're going to end with an N. Now, this is where I have problems. I don't know if you guys do or not. Uh, it was very, very frustrating here about an hour ago trying to run this code. So I'm going to run the code, and the Blinky is over here on this side right now. So we should be able to enter a failing grade 65. So you know, not with an entry of 65. What are you, a kumquat? 65. Oh, because it didn't do anything because my num locks. And see, that's what this is, you can, don't test me, computer. I'll throw you out the freaking window. Remediate, there, see, now it's giving me the right answer. Control C, and then enter. Where am I flashing? I'm flashing over there, and then a good score here would be college algebra. And then here again, and we get a 98, and poof, it puts it in the wrong freaking spot. Kumquat. And now, no matter what I do, it'll always put it. Hey, what's it doing? Yeah, see, I knew it was going to put it in the wrong spot. You, okay, trust me, it works. It's just not working for me today. Why? Why are you putting your numbers over there when I want it up here? I'm the master. You kumquat. Quit beeping at me. Anyway, I'm done with this. I hope you guys don't. If you have that problem on the exam, just put a note and I will accept it and take it and go. Why? Who's beeping at me? Nobody's supposed to be beeping at me. Okay, we gotta hurry. I'm eating up these guys this time. Okay, so here's some stuff from chapter 10. Um, this is a system of linear equations. It wants to predict whether the system is linearly independent using the determinant function. So we'll create our A vector, our A array, A not vector, array. So that's 2, 1, 5, 3, enter, space, uh, 2, no, 2, 6, 9, 2. I like doing it this way so that I can see it in vector form. You could do it all in one straight line with semicolons between the rows. Why do I have 36? There's no such thing as a 36 in this problem. A 1, a 2. a 3, and a 4. And we'll leave it so that it shows to the world how wonderful I did at making that. And then B is going to be equal to a 10, a 0, a 1. Nope, nope, back up. That's a negative 1, and a 3. Okay, and then to find out whether it's a determinant is equal to 0 or not, we do a DTE, and it comes up with a value of 196. So there is a solution to this. Yay! Otherwise, it'd be kind of silly to try and have you do part B and C if it's impossible to do. And trust me, we did that once. And a lot of students skipped it, and some said, well, if it were, this is how you would do it. Leave me alone. Okay, so left division. So left division, there's no C in division, is equal to A, and then backwards divide a B. Simple. Uh, matrix inverse is equal to B has another number in it. Does B? Oh, it does. How did you do that? I got too many ones here. Thanks. That was a test to see if you were paying attention. Okay, maybe not. I'm stupid. So then we do an inverse A times B, and poof. And the check here is if these numbers and these numbers are the same, then you pretty much got it right. Okay. Any questions? No. Okay. Last problem here. Um, is a disk moves with a rotational speed defined by the vector omega, knowing that a point on a disk is defined by the position vector, RP. Find the total velocity of the point. Can't find that total velocity is related by the cross product. Well, to me, this seems like a give me problem, but maybe I'm missing something. Total velocity is equal to the cross of omega and RP. Oh, sorry, they had a VP. Sorry, sorry. Okay, any questions? Gotta have some questions. I lost somebody. Oh, Brett left. Barrett. Evan Barrett. Oh, yeah, he said he was going to leave early. Probably got tired of my rambling on. Ooh, I hope I hit the record button because I really don't want to do that test a third time today. Oh, yeah, it's recording. I'm going to